Hi everyone. If you feel comfortable drawing the hybrid orbitals of an sp3 hybridized atom, or an sp2 hybridized atom, or an sp hybridized atom, you could use that information to put together atoms to make full molecules. And that's what we're going to do here. We're going to draw the orbital cartoon for the following molecule, and we're going to make sure all valence electrons are shown, and that each orbital is named once and only once. The molecule that we are going to examine is methanimine, and there are a couple steps we need to do first. We need to draw the lone pairs so we can determine the number of electron domains. There are no negative or positive charges drawn on this molecule, so we can assume that every atom is neutral. For nitrogen to follow the octet rule, it needs a lone pair. And next, to draw the orbital cartoons, we need to determine the hybridization state. And for this nitrogen, I teach my class to count balloons or electron domains. There are 3 balloons. Same thing for this carbon. 3 balloons, and 3 balloons represents 3 electron domains, and you get 3 electron domains when your atom is sp2 hybridized. The trick is, if you have 3 balloons, you got a result of 3 hybrid orbitals because you had mixed 3 atomic orbitals, an s, a p, and a p. What this means is that we have a third p orbital that is unhybridized. Now, any atom that is sp2 hybridized will always have 3 sp2 hybrid orbitals and 1 unhybridized p orbital, no matter if it's carbon, oxygen, nitrogen, or even one of the halogens. Let me write that down. Again, any sp2 hybridized atom has 3 sp2 hybrid orbitals and 1 unhybridized p orbital. The next thing to draw are the actual lobes of these orbitals, but also I want to show you a shortcut that I will allow if you're drawing the cartoon or the orbital cartoon for me. An sp2 orbital looks like this. 2 lobes actually, one bigger than the other, but for clarity, I would allow just 1 teardrop. And an hybridized p orbital looks like this, and I'm also using different colors, but the 2 lobes are equal size, and one is shaded and one is not. For clarity, I'm not going to do any shading. But for clarity, we still have to have both lobes. An electron can be found with equal probability in either of those 2 lobes. And this will be our drawing for an unhybridized p orbital. If you take a look at our molecule, there's a double bond between the carbon and nitrogen. So we need a sigma bond in between these 2 atoms and also a pi bond. So that will help us orient our orbitals to get the sigma and the pi bonds. Let me show you how I would start. We'll start with carbon here, and your sp2 orbitals, 3 of them, are arranged in a trigonal planar orientation. And we're going to have 1 to the right, 1 coming at us, and 1 going away from us. Okay, so it's a little bit hard to show towards us and away from us on a flat piece of paper, but imagine if this is coming towards us and this is going away, that you have a trigonal planar orientation that kind of looks like this. Okay, if it was flat on the paper, or well, I'll leave it at that. And those are sp2 orbitals. We have a p orbital, and that is perpendicular to your 3 sp2 orbitals. Now, when I said label or name, one name per orbital, what I mean there is that this is a p orbital, and it accounts for both lobes. Now, I'm going to hold off on labeling the sp2 because I don't want it to overlap any of the orbitals themselves. Let's do the nitrogen. Okay, we'll draw it a little bit close. We're going to have the same 3 sp2 orbitals and the same p orbital, but we're going to turn it around so they face each other. So there's an overlap between sp2 and sp2. We have one sp2 towards us, one sp2 away from us. And we have a p orbital right here. If I want to label one orbital one name, then I have to label this sp2, this sp2. Label this one sp2, this one sp2. This one up here, sp2, this one down here, sp2. Okay? Now, we have to account for the hydrogens. The hydrogen electron is in an s orbital, and so we have an overlap here, and that's a hydrogen, s, and an overlap here, hydrogen, s. That accounts for these 2 hydrogens on the carbon, and we have 1 hydrogen on the nitrogen, so we only draw 1 circle here. We'll use the bottom lobe, or the bottom sp2, and we have hs. So what goes here? Well, that's the orbital that contains the lone pair. So we've done a lot. We've identified the type of hybridization for each atom. We filled in the lone pairs on our Lewis structure. We drew the correct size and the correct number of lobes for each type of hybridized atom. Now we have to account for all the valence electrons, because in this orbital cartoon we should be able to see all the valence electrons. Let's start with carbon, 4. 1, 2, 3, and 4. Okay. Now, look at the bond to hydrogen. Hydrogen brings with it 1 electron, so that's now a sigma bond, complete. This one here, complete, sigma bond. Now what about nitrogen? True, nitrogen is sp2 hybridized, so it's identical in the number of hybrid orbitals and p orbitals. But nitrogen has 5 valence electrons, so it has to make sense where you put those 5 dots. Just remember that 1 orbital can hold a maximum of 2 electrons. And so, to complete the sigma bond here, let's put 1 electron for nitrogen right there. To complete the sigma bond over here, let's fill in the electron for nitrogen and the 1 for hydrogen. That's already 2 for nitrogen. To complete the pi bond, because there is a pi bond here, let us put in an electron on this p orbital right there. That completes this pi bond between the 2 p orbitals. Nitrogen has 5 valence electrons, and we only drew 3 so far. 1, 2, 3. But guess what? That lone pair, that sp2 orbital is empty, so we could fit both electrons of the lone pair here. And that tells us a lot of information. That tells us, literally, that lone pair is in an sp2 hybridized orbital, not in a p, and we're not splitting up the 2 electrons. That looks good for the complete orbital cartoon for methanimine. And just as a bonus, if I drew out the Lewis structure, how does this cartoon help? This cartoon helps because I can literally look at what is overlapping to make that double bond. There's a sigma bond between an sp2, sp2. 1 on the carbon, 1 on the nitrogen. And there's a pi bond between the 2 p orbitals, carbon p and p. Okay, so that's just a little bonus. Let's do this one as well. Sigma N sp2 for this teardrop, and hydrogen S. Just for completeness, let's do this one here. Sigma carbon sp2 hydrogen S.